C++ supports both template functions and template classes. In this movie, we'll be looking at template functions. Let's make a working copy of templatefunction.cpp and we'll paste it into our working project here. Here we have a simple example of a template function that gives the maximum value of 2 parameters. The keyword type name is commonly used here on line 5 to indicate the type that will be templated. But the keyword class also works and is often used. Just be aware that, at least in this context, either of these tokens means exactly the same thing. This simple template is both type agnostic and type safe. It's type agnostic in that it will work for any type that has support for the greater than operator. And it's type safe in that the compiler will generate a specialization of the function for that given type. So if we call it as we have in line 10, with 2 integers, it will generate a specialization of the function that operates on type int and returns type int. So I'm just going to compile and run here, and you'll see that our result is an int. And if I change this so that it has 2 string literals, now it'll generate a specialization that works on C strings and returns a C string. So I'll compile and run, and we see that it thinks the AAAA is larger than the BAAA, and that's because C strings don't actually work very intelligently with the greater than operator. On the other hand, if we tell this to use the C++ string class instead, and we can do that by specifying it like that, and now we compile and run it, we see that we get a more intelligent result because the C++ string class actually supports the greater than operator properly. So let's take a look at a slightly more complex example. Go ahead and delete this, and we'll run clean. Make a working copy of join.cpp. They're out of our Chapter 10 folder in the exercise files, and open it up. Let's maximize this so that we can see it. And I'm just going to scroll down a little bit so that those folks who are typing along at home can follow us. So this function will take any container, and it'll join the elements into a new container with a separator between each element and return the new container. And down here in main, we'll see a couple of examples of how this is used. The first example on line 23 joins the characters of a string with a separator of a colon into a new string. And the version down on line 27 joins strings from a vector, and it separates them with a comma and a space. So let's take a look at how this works. So you see that the template declaration specifies 3 different types: the container type, the return type, and the separator type. So these can all be the same, or they can be 3 different types. You'll notice that 2 of them have default types. The second one here, type name return type equals container type. And so if a return type is not specified, it'll default to container type. And the third one is a little bit more complex, separator type, and if it's not specified, then it'll default to the value type of the container type. So you can see you can do a lot with this. Most of the time, this level of detail is not necessary, but I just wanted to show you how powerful this can be. The function itself, it returns the return type, and it takes 2 arguments, an object of the container type and an object of the separator type. It declares a temporary variable for the return type called out. It sets up an iterator, and it iterates through the container and takes each object and concatenates it into the out container. And if we're not at the end, it adds a separator to out, and then it returns out. It's really very simple. So let's go ahead and bring this back down and run it. So we'll press the compile and run button there. And we see how powerful this is. We've taken a string, S1, that says this is a string, and it's taken each character and separated them out by colons and created a new string with that result. And then it takes a vector of strings, which is like an array of strings. A vector is a C++ container type. And so it's got all 3 of those strings. This is a string, this is also a string, yet another string. And it joins them into a string. See, its output container is specified as string, and the separator is a string containing a comma and a space. And so our result here is All these strings separated by a comma and a space, all in one string. So you can see how powerful and flexible this is, and it's just this simple bit of code here, and it can do all of that, and it can work in all of these different types. It can really work with any container type that supports those operators. It just needs to support that plus equal operator, and that's really all that's necessary. So template functions are a form of generic programming that are easy to create and can be very powerful and very useful. For many of the purposes that we used to use C macros, C++ template functions are more powerful, more flexible, and less prone to error. Let's delete our working file and run clean to get set up for the next lesson.